Harvard Mark Wurst, officially known as the IBM Automatic Sequence Controlled Calculator, ASCC, was an early electromechanical computer that marked a significant milestone in the history of computing. Developed between 1937 and 1944, it was a collaboration between the American computer scientist Howard Aiken and IBM, one of the leading companies in information technology at the time. The project was initiated after Aiken, who was a professor at Harvard University, approached IBM with the vision of creating a machine capable of automating complex mathematical calculations to assist in scientific and engineering work. This endeavor was not only groundbreaking for its time, but also paved the way for future digital computers. The design of the Harvard Mark I was influenced by the mechanical computers of the early 20th century, but it combined these with the technological advances of the 1930s. The computer was a hybrid of electrical and mechanical components, which is why it was classified as electromechanical rather than fully electronic. At its core, the Mark I utilized electromechanical relays and rotating switches to perform its calculations. The machine was constructed from a series of interconnected panels filled with gears, clutches, and electromagnetic relays, which allowed it to execute instructions in a sequential manner. This combination of mechanical and electrical systems made the Mark I more reliable than its purely mechanical predecessors, as the electromechanical components were less prone to the wear and tear that affected mechanical parts. One of the most notable aspects of the Harvard Mark I was its size and complexity. It stood approximately 51 feet, 15.5 meters, long, and 8 feet, 2.4 meters, high, taking up a considerable amount of space in the room it was housed in. The machine was comprised of over 750,000 components, including relays and switches, which worked in conjunction to perform calculations. The Mark I was able to carry out basic arithmetic operations such as addition, subtraction, multiplication, and division, as well as more complex mathematical functions involving trigonometry and logarithms. It was programmed using a series of punched paper tape cards, which were fed into the machine to dictate the sequence of operations. The operational speed of the Harvard Mark I was not as fast as modern computers, but it was a significant advancement for its time. The machine could execute a series of instructions at a rate of about one addition or subtraction per second, and more complex operations like multiplication and division took longer to complete. While this speed may seem slow by today's standards, it was an impressive achievement for the era and provided a powerful tool for research and scientific computation. The reliability of the Mark I allowed scientists and engineers to conduct calculations with much higher accuracy and efficiency than was possible with manual methods or simpler mechanical devices. The Harvard Mark I was also noteworthy for its role in advancing the field of computer science and influencing the development of later computing machines. It demonstrated the feasibility of building machines capable of executing sequences of complex calculations automatically, laying the groundwork for the development of fully electronic computers that would follow. The success of the Mark I was instrumental in bringing attention to the potential of computing technology, which would eventually lead to the creation of the more advanced and faster computers that came in the following decades. The machine was used extensively during World War II for military and scientific applications, contributing to the war effort in ways that were critical to the development of new technologies. The Mark I was used to solve complex mathematical problems related to the design of weapons, ballistics, and other military engineering tasks. It was also used for various calculations for research purposes, which included work related to radar and cryptography. The impact of this machine in the wartime context was profound, as it allowed for the processing of data and the solution of problems that would have been far too time-consuming if done manually. Howard Aiken's vision for an automated computing machine had a lasting legacy. After the completion of the Harvard Mark I, the collaboration between Harvard University and IBM continued to produce more sophisticated computing systems, such as the Harvard Mark II and Mark III. These machines laid the groundwork for the transition from electromechanical computing to the fully electronic computers that would dominate the post-war period. The concept of storing and processing data in sequences of instructions, known as a stored program, was implemented in later computers, leading to the development of modern computing architecture. The Harvard Mark I's influence extended beyond its direct use, inspiring future generations of scientists and engineers to explore the potential of computers for more complex and varied applications. Despite its limitations in speed and processing power by today's standards, the Harvard Mark I was a revolutionary achievement in the 20th century and an essential step in the evolution of computing. It represented a bold leap forward from mechanical calculators and set the stage for the innovations that would follow in the world of computer technology. The machine's legacy lives on, not just in the context of its direct impact on computing, but in its role as an iconic symbol of human ingenuity, engineering excellence, and the relentless pursuit of progress in the face of the unknown. Thank you for watching. We have some amazing videos coming up, so stay tuned and make sure to hit the subscribe button.